All right, guys, I'm going to go ahead and go through the notes on multiple transformations happening on these functions. All right, so we're going to do 5 different ones. Okay, so the first one is the quadratic function. All right, so this idea is the parent function is quadratic. So I'm going to write x squared would be the original one. All right, if you guys remember, the original points for that was -2, -1, 0, 1, and +2. All right, and the original y values, when you square those numbers, you get 4, 1, 0, 1, and 4. All right, so we're basically going to do 3 different transformations to this original one, and I'll graph the original one for you. All right, it looks like this. That original parabola. Okay, so the first thing I notice is that we have a transformation inside parentheses. All right, you should know that is a horizontal transformation. So we're going to be moving 2 units to the left because of that inside the parentheses. Then we have outside the parentheses of -1. So that's going to be 1 unit down. And then finally, this last one in the very front, this 2, right, that is going to be a vertical stretch by a factor of 2. Okay, so basically what's going to happen is going to look a little bit skinnier with the parabola, right? I'll say this right now, but I will definitely do it in class many times. If you take like a string through your body and then pull the string up to kind of like stretch you out, right? That's what a vertical stretch. That's what you should think about when you think about a vertical stretch. All right, so in terms of the new points I'm going to use, because of this movement horizontally, I'm going to take each of these x values and move them 2 units to the left. So essentially subtracting 2 for all those x values. So instead of -2, that's a -4. Instead of -1, it's a -3. I think you get the idea. Just moving them 2 units to the left. Now, when you do that, when you plug in those values, right, and you can plug them in using a calculator if you want, or you can actually go in and plot it. I'll show you how to do that. But the idea is that we can plug them in, like -4 plus 2 is -2. Square that, you get 4. 4 times 2 is 8. 8 minus 1 gives you 7. All right, so I'm not going to like take the time on this video to show you that. We'll do that in class. You have a calculator. I know you can plug something in. I'm using Desmos as I do this video to help me with the points. So that's what I'd recommend too. If you want to use Desmos, go for it. All right, so this next y value is +1, then -1, then +1, and then 7. So let me show you kind of like what I'm hoping you can do. I'm hoping you can move this vertex point 2 units to the left and 1 unit down. Right, that's what everyone should be able to do. So that's why we have -2, -1, that point right there. Okay. Now, the reason you can't just make the same parabola like you just did on the original is because of that vertical stretch, all right? But what you could do is you could move 1 unit to the right, and when you square 1, you get 1, all right? But then you would have to multiply that by 2. I'm just going to use the rest of the y values to plot, but I'll show you in class kind of the way that my brain can figure this out without actually making the table. So we have -3 is going to be +1. You might notice that's 2 units above where the last one was. And then we have -4, +7 right here, and then 0, 7. So it's going to be a little bit difficult to see, but I think you will be able to see that this orange one should be a little bit skinnier than the original parent function in black. All right, so that's the idea, is that because of that vertical stretch, this is going to increase at a quicker rate. So it's a little bit skinnier than the one in black. All right, so that is this quadratic one. Let's quickly talk about the domain and range. The new domain, all right, in terms of the x values that we can plug in, because of that 1 unit down, I am able to plug in -1 and then continuing all the way up to infinity. I don't know why I wrote that. I apologize. I'm sorry. That's not the new domain. The new domain is the same as the old domain. It's all real numbers. You can plug in any number you want to a quadratic, no problems there. You'll be able to get a value. What I wrote down, I apologize, was the new range. The lowest y value is now -1, and the highest y value is still infinity. All right, so the new range is going to be -1 included, so bracket to infinity. All right, there we go. That makes more sense. That's the first one. Let's do the next one. The next one is the square root function. All right, and so this parent function is the square root of x. When we graph the original one there, we only want to use positives and perfect squares to graph this. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And I put the 16 there, but you'll notice that we cannot actually plot 16 comma 4 on this grid, but it is the next perfect square. All right, so there is the original square root function. All right, so now the new one here, based on these transformations, is I see inside, let's get some new colors here. Inside, I see -3, so that's going to be 3 units to the right. And then outside, mix it up. Outside, oh, that's the same one, Douglas. Let's try one's different. Ooh, fun. Outside, I see +2, so that's going to be 2 units up. I don't see any vertical stretch or compression or anything else, so it's just going to be 2 transformations here. And when I look at this one, all right, because of that 3 units to the right, I'm going to take each of these original x values and move them 3 units to the right, so +3 for each of those. So that's going to be 3, 4, 7, 12, and 19. All right, again, you can go ahead and plug them in if you want into a calculator like I did in Desmos before I started making this video. So 3 minus 3 is 0, square root of 0 is 0, plus 2 is 2. All right, the idea is the y values are going to move 2 units up, all right, because of that vertical shift. So if we're going 2 units up, this one should be 3, 4, 5, and 6. All right, so plotting those points, I'll plot a new one here. Let's use green. I'm going to be plotting 3, 2, 4, 3, 7, 4, and then I can't do 12, 5. That would be off the grid. All right. Now, the nice thing about this, I know it might be a little tough to see because I don't have that many points with the green one as I do as the black one, but they should actually look identical. All right. I know that they're in different locations, but the transformations that occurred here were just shifting it, sliding it horizontally and vertically. We didn't actually stretch it, compress it, or anything like that. So this should, in theory, look exactly the same. Now, it is going to change the domain and range. All right, so the new domain, the new lowest x value is going to be 3. And then we can plug in anything that's to the right of that 3. In terms of the range, the new low y value is at +2, going to positive infinity. So that is letter B, the second one, transforming the square root function. Let's do a third one. All right, so this one is the absolute value function. Or when you graph this one, you should remember this is a v, so the absolute value of x. So we can graph that one real quick. Really, it's just 2 lines. Right, one with a positive slope, one with a negative slope to make that v. All right, so there's the original one. Pretty straightforward for these original points. The absolute value of any of these numbers will just be positives. All right, hopefully that's not too bad. Now, how are we transforming this? So in terms of what I see the +3 inside. So that's going to be 3 units left. Remember, think opposite inside. Then I'm going to look outside. That's 4 units up. And then after I do that, the last thing I see, and this is the first time we've had this, in the front, I see that negative sign. When you have that negative sign in front of like the beginning of it, right? It's not the opposite of the whole thing. It's just that absolute value. This is going to be a reflection over the x-axis. So reflection over the x-axis. So essentially my v is going to turn into an upside down v, or like an a without like the line that makes it an a. All right. But in terms of my new x values, all I care about my new x values is I care about the horizontal shift. So that 3 units left means that all of these values in the x are going to move 3 units to the left or subtract 3. So -2 minus 3 is going to be -5. Keep going on all of these. Right, and the idea is that that's how you find the new x values. Using a calculator or using Desmos, right, you can make this function, you can plug in these x values. I'll show you how to make a table in class. So you can do this on your laptop, on your phone, whatever you have, to get those y values, okay? So my y values are gonna be 2, 3, 4, 3, and 2. So let's graph this new one. This new one is -5. Let me show you how to do it without actually plotting these points. I mean, I am, but not using the points. So here's what I do. I'm going to the vertex. The vertex is 0, 0 for the parent function. Move 3 units to the left, so 1, 2, 3. 4 units up, 1, 2, 3, 4, and you make the new vertex, okay? Now, because we're reflecting over the x-axis, I'm going to make this V upside down, or like an A. And if you were to look in my table and look at these blue points that I just plotted, these are the points that I just plotted. I know I plotted a few extra, but I did plot -5, 2, -4, 3, and so on and so forth. So anyway, there is this new function opening down. Okay, so that is the absolute value function. Let's do the new domain and range. In terms of my domain, I can plug in any x value left to right, so no issues there. -infinity to infinity, I can plug in anything I want, and I'll be able to get a y value. In terms of the range, though, because we're now opening down as opposed to opening up, that's going to change everything. My lowest value is actually going to be -infinity, right? The arrows in blue are going down forever, so always starting and thinking least to greatest. So -infinity is going to be the start of that, and the highest y value goes up to that vertex point of -3, 4, so the y value is 4. We are including it, so I'm going to use a bracket. All right, so that's the absolute value function. All right, let's do 2 more. We're almost there. All right, so this is another square root function that we are going to transform. Again, we did this one, I think, in letter B. The original points are going to be those perfect squares. Don't think I'll be able to graph 16,4 again, no problems. But I can make this same one that I just did in part B, that half of a parabola on its side. All right, now this one can be tricky here because I don't see any horizontal or vertical shifts. I just see negatives. So I'm going to start with that negative that's inside, right? That negative inside is different than the negative we just did with the absolute value function. That was on the outside. So this time the reflection is going to be over the y-axis first, not the x-axis. So the negative inside is a reflection over the y-axis. Okay? Then the next one out front, that out front is like we did on the previous problem. Then we're going to reflect, so reflection over the x-axis. So we're going to do 2 reflections here. We're first going to flip it over the y-axis, then we're going to flip it over the x-axis. All right, and so I'll show you kind of a quick, right now I'll just show you real fast, and then I'll erase it. So over the y-axis would be like this first. Ooh, that was cool. I do want to do a curve. Let me just erase that. I learned what I just did. So like that first, and then we'll reflect it over the x-axis, right? So it reflect over the x-axis will be down here. So we're going to end up down there. I'll erase those and do it for reals, but that's essentially what we're doing. Okay, so for the new x values for this one, right, I can't use the 0, 1, 4, 9, 16, because if I use those, the first thing to do is make them the opposite. And yes, I'll be able to use 0, but all the other numbers would become negatives, cannot take the square root of those negatives. So I actually have to make all of these numbers the opposite. So I have -16, -1, not -1, -9. Let's go least to greatest. -4, -1. I told you 0 is going to be okay. All right, so then you're going to take the square root, but then because of the negative out front, the y values become a negative as well. So we have -4, -3, -2, -1, and 0. So here's where it ends up. Hopefully you're not too surprised by this. So 0, 0, -1, -1, -4, -2, and -9, -3. So that's what I was trying to say, that we're going to end up down here after both of those reflections. Now, technically, you could do whichever reflection you want first. It shouldn't matter. And what's kind of cool is it's kind of made what something kind of looks like the cube root function. It's not, but it kind of looks like it. You could technically, if you wanted to reflect over the x first and then over the y, you end up in the same spot, but I'm going to go in the order that we did. So the new domain of the blue one, all right, in terms of my x values, I can plug in any negative value all the way to -infinity, right? Because when I plug that in, the first thing it's going to do is make it the opposite underneath that radical, all right? But then my highest x value is actually going to be 0. I can't go past 0. If I plug in any positive x's, I'm going to have an error message in my calculator. In terms of the new range, my lowest y value is going to be -infinity, and my highest y value will also be that 0 included. Okay, one more. We've made it, our very last one, the cubic function that we're going to transform. So x cubed is the original. The original points there are -2, -1, 0, 1, and 2. When you cube them, you get these y values. So if I plot that original one, I'm going to make that the way we kind of described it in the previous video was, think of like you have this river that's curling up the y-axis. So it looks like this. All right. And we're going to transform it. So let's look at all the transformations we have here. First one I see is inside. I see -2, so that's going to be, think, opposite, 2 units to the right. Then I'm going to look at this +3. That's going to be 3 units up. But then this is the first time we've had a fraction in front. We did have a number in front in the first one, but that fraction in front means we're going to have, because it's between 0 and 1, right, because that fraction is between 0 and 1, we're going to have a vertical compression by a factor of 1/2. All right, so essentially, instead of a stretch, like we had in the very first one where it became skinnier, this one's going to become a little bit wider. All right, so it's not going to increase as quickly. But in terms of the new points for the table, all I'm worried about is the horizontal shift. So 2 units to the right means all of these x values in the original are just going to move 2 units to the right. So that's going to be 0, that's going to be 1, 2, 3, and 4. All right. Now, when I plug those values in, I am going to end up getting fractions or decimals, because at the end I'm going to multiply by 1/2. So if you plug in 0, you get 0 minus 2. This one won't be a decimal, but -2 cubed is -8. Half of that is -4. -4 plus 3 is -1. This next one will be a decimal. 1 minus 2 is -1. You cube it, you get -1. -1 times 0.5 is -0.5. -0.5 plus 3 is 2.5. So again, you are going to have some decimals here. That's okay. I think you'll be fine when we plot them. All right. So let's go ahead and plot these new points. I'm going to plot 0, -1, 1, 2.5, 2, 3, 3, 3.5, and 4, 7. So you see everything's like just a little bit kind of smushed together, right? Compressed, if you will, right? Not as spaced out. So that 1/2 is just making it a little bit wider instead of a little bit skinnier. All right. Okay, do the domain and range, then we'll be done. This one should be hopefully straightforward. Even though we have compressed it a little bit, with cubic functions, you can always plug in anything you want, and you're always going to get any y value as well when you plug in any x. So the domain and range is going to be all real numbers for both, or what I write is -infinity to infinity. Okay, so hopefully you guys will have a chance to try the homework, submit that, and then come see me if you have any questions.